Hi, this is Miss Zainab and I'm going to be talking to you about binary today. So there are three parts that we're going to go through. First of all, we're going to talk about what are binary numbers. Then we're going to look at converting binary numbers into denary numbers. So denary numbers 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then we're going to look at bits and bytes. So we're going to look at how many bits it takes to make a byte and how binary numbers are used in memory. Okay, let's get started.
Okay, so binary. When we first hear about the word binary, sometimes the first thing that comes into our mind is something to do like this. Some form of movie, and we've got zeros and ones spouting all over the place. Now, obviously, with zeros and ones, they are a little bit different. Zeros and ones actually mean something, and they're actually symbols. So there are two different symbols that are used in binary. The first one is 1, and the second one is 0. So what does a computer actually understand from 1 and 0? Well, 1 means on and 0 means off. Now if we put these binary numbers in an 8-bit format, they actually mean separate numbers. So the ones that you can see in front of you are all different types of numbers, but they're put in an 8-bit format. Where the 1 and the 0 are positioned determines what the number will be. So I'm going to show you exactly how we're able to decode this, decoding from binary to normal numbers and normal numbers back into binary. For your GCSE course, you have to show an understanding of how you would be able to use 16-bit. Now, this works in exactly the same way. If you were to have a normal 8-bit number, and if the exam question asked you to be able to turn it into a 16-bit number, you would just fill in the zeros. And then if you count how many positions that there are, you can see at the top there are 16 positions. And I've put another example of a binary number at the bottom there. Okay, so right now this might look completely confusing, but in about 2 minutes, you will be able to work out exactly how to make the conversions between the two. Okay, so right in front of you, you will see a binary number. Now this binary number is 0, 0, 0, 0, 0, 1, 0, 1. So we're starting off with a very, very simple one at the beginning. Now remember what I said before, that each binary number holds a specific position, which is really important. So you can see in the first position, we'll be actually reading from right to left. So each position has a different meaning. Now, so first of all, we'll look at the first position, which would mean a 1. The second position would mean a 2. Now, each time we go up, we're going to be doubling. So you can see the third one would be a 4. The next one, you guessed it, an 8. Next one would be 16. And we're doubling again to 32. And then we're doubling again to 64. And then we're doubling finally to 128. Now, if this was a 16-bit, we'd continue at this point. But at this, what you'd need to know at this stage is only for 8 bits. So now you can see where the ones are positioned. And so if you have a look at the first number on the right, the one that I've circled in blue, that has a 1 on top of that. Then we look at the second one, which has a 4 on top of that. So there are no other ones in that binary number. So these are the only two that we're going to focus on. Now, all you need to do at this point is just add these two numbers up. So you'd only add 4 plus 1, which equals to 5. So it's easy as that. 0, 0, 0, 0, 0, 1, 0, 1 means 5. So simple. So it's just the idea of adding up the two positional numbers, which will get you the answer. Okay, so let's try again. Now we're going to try it with one that's a little bit more difficult. So I've added a few more ones you can see on the left-hand side. So we just use exactly the same method. So we identify the positions. So we've got our positions in 1, 2, 4, 8, 16, 32, 64, and 128. They never change. Okay, so we're always going to be using these numbers at the top. So then we've got our first one, which is 1, circled in blue. Then we've got our second one, which is 16. And we have a third one this time, which is 64. So what do we need to do?
we need to add all of these numbers up. So 64 plus 16 plus 1 equals 81. So the binary number 01010001 equals to 81. Easy. Okay, so now we know how to be able to convert binary into denary or normal numbers, but how can we do it the other way around? So we now need to focus on converting denary over into binary. So this is again really simple. So first of all, let's start off with a small number, 13. So what is 13 in binary? Now I've already put the positions there in front of you. You can do this in an exam as well. So if you were asked what is a particular number in binary, you can actually just write these numbers out to help you to try and work out what the number is. So I've put the positions in for you, and the next thing you need to do is work out where you would put your first one. So my first one that I've put in is under the position 8. The reason being is that the number 13 is smaller than the number 16 but higher than the number 8. So this is the position that I would put it in. I would put it in 8. I can't put it under the 16 because that would be too high. So I want to be able to catch all the numbers under 13. So the first one, I put my first one under 8. Then I would take away 8 from 13. So I do 13 minus 8, which is equal to 5. Then all I need to do is then use exactly the same method. So I would then put a number 1 next to the next number, which would be 4. Now the reason being again for that is our number 5 is larger than 4 but less than 8. And I wouldn't put it in 2 just yet because 4 can still fit into 5. So therefore my 1 goes under 4. So again, we apply exactly the same method. We then take away 4 from 5. So we do 5 minus 4, which is equal to 1. Now, 1's a nice number to finish on, so our 1 can fit neatly under the 1, which then leaves us with nothing else, which is perfect. So the last thing for me to do is to be able to fill in all my little zeros, and there's my binary number. 0001100 is equal to 13. Okay, perfect, easy. So let's try a much larger number. So let's try 72. So the same rules apply. Our first one would go into where? Would go into 64 because it's less than 128, but 72 is higher than 64, so I would place a 1 there. I would then do 72 minus 64, which is equal to 8. So then I can put my 1 in neatly under the 8, which fits in perfectly. So therefore, I can then fill in my zeros, and then I'll end up with 0, 1, 0, 0, 1, 0, 0, 0 equals 72. So how easy was that to be able to convert between denary numbers and binary numbers? So simple. Okay, so have a few goes with some other numbers yourself and try to do some switches between the two. At the beginning, it's always a bit, it might take a little bit of time. But over time, once you start practicing how to do it and you keep going back and forth between the two conversions, and then you'll just get better at it. Okay, so the next part is we're going to look at our bits and bytes. So now this is more to do with memory sizes. When we look at binary numbers, I said before that this was an 8-bit binary number. Now, as you can guess, the reason why it's called an 8-bit binary number is that each part is a bit. So that takes up a bit. Whether it's a 1 or whether it's a 0, it would take up a bit. So in this would take up 8 bits. Now in terms of memory sizes that you have to know for your GCSE are 8 bits is equal to 1 byte. So my next video will talk a little bit more about different types of memory sizes and what they mean. But at this stage, in terms of binary numbers, we know that 8 bits is 1 byte. So if it was 16 bits, then we know that this would take up 2 bytes. It will be the same thing. And there you have it. So we've gone through what are binary numbers, how do we convert between binary numbers and denary numbers, so how do we convert between the two, and then we've also talked about bits and bytes. I hope you've enjoyed this lesson, and I hope to see you soon.